Hello guys, today we are going to actually try to wash the membrane with help of citric acid, and uh, we will try to recover this membrane. This has been very badly used, and water flow was literally zero. This membrane, I washed it with regular water, but no results were coming out. So we will try to wash it with the bath of citric acid. For that we will require 25 to 30 liters of water. Now here I have taken RO water, and we will require a pH meter, a digital pH meter, or you can use a manual also. So first thing we have to do is it is always better to have hot water. So what I will do is take some part of this RO water and heat it up, and then again put that water in it. So at least we must at least have a temperature of 50 degree, almost 45 to 50 degree, not too hot, at least 45 to 50 degree, so that we can put the membrane inside that. So I'll take some water from this, and I'll heat it up, and again we will start and we'll proceed again. Okay, right now the TDS is 7 ppm, and temperature is almost 44 degree centigrades. So actually I was trying to get it 50 degrees, but 44 degrees is okay. If it is 50 degrees, it is very good. And now we will take the reading of pH of this liquid. The pH is showing 8. It is somewhere around 7.9 to 8. Okay, so now we are going to add citric acid to it. So first this is the citric acid which I have got. This is food grade citric acid. It is 25 grams. Entire pack is there, 25 grams. This is normal food grade citric acid. Okay, so this is a half teaspoon. I am going to use it for the measurement of the citric acid, and I use the membrane itself for stirring purpose, because ultimately we have to insert the membrane inside it, suspend it. So first I'll add citric acid. We are trying to lower the pH of the solution. I'll first add a half teaspoon. This goes the first, and I'll mix it with the membrane itself. As the solution is in a huge quantity, I have created the solution, because first we are just immersing the membrane inside that. Later on we will flush the membrane with this solution using a motor, a pressure motor. We will run this chemical through it. So I am using this. Now we will again take the reading of pH. Always remember to calibrate your pH meter first. Okay, the pH has dropped to 3.6. So this has already become a low pH solution. So remember that the pH should not drop below 2, otherwise it will damage the membrane. If you want, we can add only a little bit of this solution. A little bit means half teaspoon is enough. It has already dropped from 8 to 4. It has already dropped 50%. The pH of the solution has already dropped, so I will be adding very minimum amount, only this much, a pinch more, to reduce it to further more. Again we will mix up the solution. People always think that adding too much of citric acid will help, but remember, it will not help. It will damage your membrane permanently. So again we will take the pH reading. It has come to 3.6 now. Our target is to bring it to 3. So I'll add a little pinch of more. I'm doing this because I don't want the now I've taken I don't want the solution to go below 2, because of that I'm adding very small amount of citric acid, because this can happen, and if that happens, I'll have to create the entire bath solution again. For that only I had already taken RO water, because RO water is generally acidic, but because of my alkaline filters, the pH was maintained to. There is no change. More pinch of it. Remember, because the solution is changing, it will take time to show the accurate pH reading. It is sufficient. I think 3.6 is sufficient, and we will let the membrane sit in the chemical for at least 1 hour. After that I'll come back again and we will flush the membrane with the chemical solution. This membrane was not giving any flow, it was totally blocked, so we will try to see if this really helps. So I let this membrane sit for at least 1 hour, and then we'll come back again and check to it. Thank you. Okay, so we decided to add some more pH here, because the pH is still, it is 3.5, so we decided to add a little bit more solution, citric acid, to it. So this is the third pinch I am adding, very little amount. Stir it, the membrane. Now we'll check the pH again. Is it reduced to some extent? It is reduced to 3.4, only single point. So I'm gonna take some risk and add more of citric acid to it. Now I'm almost up to quarter teaspoon adding. Let us see how it responds. Remember, I don't want it to go less than 2, so I am doing this. Let it sit for some time and then we'll again see the pH. Hello guys, sorry we had to change the setup location because it was too dark outside, so I had to come inside the home. And it has been more than 2 to 3 hours for which my membrane was completely immersed into the solution that we created. And now what we need to do is I have got a pump, a normal booster pump. What I am going to do is, this is a 100 GPD pump. I'll put the inlet of the pump over here into the solution directly, and I am going to put this membrane into the membrane housing. I'll insert this membrane which was immersed into the solution into the membrane housing. And put the lid on again. I'm going to make a mess in my home. Now I'll attach a pipeline to the drain outlet. I have connected all the cables, the power supply to the pump, and to the outlet I am going to attach a manual flush like this. If you don't have this, don't worry, just attach the manual flush. This pipeline which goes into the pump, and my membrane is inside this. I'll adjust the camera to get more space just a bit behind so that we can display the entire setup. Okay, here is the pump and here is the membrane. So the outlet coming from the pump is over here, the out pump. I'm going to put the outlet from the pump to the inlet of the membrane where we normally put the motor connection, and nicely secured. So right now I'm going to just run this entire setup, and I'm going to keep this as on. The flush valve is on. I have not attached any flow restrictors or anything. So this is the 2 buckets and 1 motor, and now I'm going to plug it on. I have plugged on and the pump has started pumping the solution into the membrane. The solution is coming out from the drain. Let us said that you should check if any particles are coming or not. Otherwise, directly you can put this water into the inlet solution where generally the water is coming. You can directly put it over here, and means the water is coming from this bucket, and I checked if any bad contaminants are coming out, which I am seeing not any. So I again put the out pipeline directly to the inlet source. Now it is running into a loop sort of. It's coming from here, it's going into the membrane, it's coming from the drain and again going to the same bucket, that is the red bucket which we had the solution of okay, the citric acid solution. So I'll let it run for a few minutes like this only. It will complete the solution, it will complete the cycle. We at least have to do this for, you can say, 30 minutes is sufficient. 15 to 30 minutes. What this will do, it will pump the low pH solution into the membrane deeply, and that will cause the scaling to get descaled. After 5 to 10 minutes, what we'll do again is that we'll remove this pipeline over here and I'll bring it over here. What I have to do is close this knob some sort of time, and again I have to open it and close it for some time, let the pressure build and again open it up. Close it for a few seconds, again open it. That will cause the pressure to build into the membrane. This will cause the scaling to be loosened to some extent, as there are no visible contamination as yet to be seen. But this is the only said method. We have to run this for at least 10 to 15 minutes, and I'll get back to you after a few more time. Okay, after 5 to 10 minutes of running, what we have to do, first we need to close this knob and shut off the motor and let it sit like this only. Let the entire setup sit like this only. Actually, we need to also apply another actually we must apply one more this thing to block, so I'll have to open it and again I'll have to put it, because we need to close it over here also at the mouth, so it should be totally closed. So I'll have to pump it again. Pump it again. I'll have to open this again for some time. Then close this tap. Let the pressure clean. Close it here also. Once both the inlet and outlet are sealed, and let it sit for some time again in this condition only. At the top I had applied a wall, at the drain side I have applied stopper, a tap. The solution is completely trapped inside the membrane, and you can see the pressure is generated and water is trying to escape from this region, that is causing the scales to be removed. And we are hoping that by doing this thing, we are hoping that it will cause enough pressure to descale it. So I'll keep this for some time, and again we'll give it some again we'll start the process. Okay, after 1 hour of soaking, I have again started the pump. I opened both the valves. The water is flowing through the membrane again. I let the water flow a little bit. Around 5 minutes of water flowing through the membrane, you can notice that some amount of water started dripping from the outlet flow. Means some water is getting filtered, some pores have already started to open up. The water here was around, it's still warmer than normal water. Now I'll stop the pump. Now what we have to do is we have to remove the head, the pump entrance, and we have to replace the pump flow to the reject water head side. That means over here, the reject water side. We have to pump the water from the same water from the reject side of the water, and we have to again rotate the process. Now I'll start the pump in the reverse side. First check that any contaminants are coming over. So first I'll drain it in this tub into the water, and I'll again stop the pump and open up there. Now we have to recycle the water again from the reverse side for a few minutes. This is a lengthy process, I know, but I am trying to curb it as small as possible. After pumping, again I'll stop this for some time, generate some pressure, and release it. Stop, generate some pressure, release it. Now I'll stop it, generate some pressure, close the pump and close it over here also. Both the sides have closed, and I'll keep this again for a few time. The pressure will build up into the membrane, and after this we will flush the membrane with our regular tap water, and we'll check if whether this process is working or not. I'll keep this for almost 10 minutes, and then again we will check for the membrane, is it performing or not. I have again started the motor and started pumping out the water again. After 5 minutes of this process, we will put the membrane to the fresh water, tap water, and see if our this much work, whether it helped to reopen the membrane. We'll check it if it has reduced if it has removed the scales of the membrane. So for 5 minutes I'll pump it with this solution, and this solution can be used again for other membrane also. You can use it for two membranes. After that you have to throw it away, because if scales, eventually the scales are deposited into this water. Okay, I have attached the membrane. I started the motor. I have attached this to the regular normal tap water and flushing it completely. We'll need to flush it at least for 1 hour to remove all chemicals from it. We'll close the valve for some time, let the pressure build, release the pressure, let the pressure build. Now we'll attach the flow restrictor. And the flow restrictor. Now it is the flow restrictor FR450, and water flow has started coming out. From the water, some amount is coming. Before it was nothing. Very low amount. Water flow is very low. This is the only possible method, but it is not so much of promising. There are other chemicals available, high, low pH chemicals. Basically, the problem is that some scalants require high pH solutions to be removed or to be descaled, and some scalants require low pH solutions. So we tried with a low pH solution, and we at least managed to open up the membrane with some amount of water is coming out. But to open it, others to remove other contaminants and other scalants, we will require also to follow the procedure with high pH solutions. High pH solutions like alkaline solutions like baking soda can be used with the similar process, but again the alkaline level should not cross 9 or 10, again to avoid clogging of the membranes. Thank you very much. If you have any suggestions or any questions, please ask and I'll try to answer them. Thank you.